Good morning to all. I am Professor Navneet Kaur from Department of Electronics and Communication from Sagar Institute of Research and Technology College. Today I will be discussing lab practicals of subject Digital Signal Processing EC 601. Now first I will show the list of experiments in which I have given all the 10 practicals. Today I will discuss third practical. Write a MATLAB program to find and plot even and odd components of a signal. In this practical, the software used is the MATLAB software. First, I'll discuss the theory of this practical. We know the even signal is the signal which has even symmetry with respect to y-axis. That is, x of n is equal to x of minus n. Similarly, the odd signal is the signal which has anti-symmetry with respect to the y-axis, that is x of n is equal to minus of x of minus n. Now every signal is composed of even as well as odd component. Now if a signal xn is given, then its even component is computed by the formula half of x of n plus x of minus n, where x of minus n is the folded version of x of n. Similarly, the odd component of signal is given by the formula half of x of n minus x of minus n, where x of minus n is the folded version of x of n. Now, first we will see the MATLAB code. Now, for continuous time signal, if I want to plot even and odd component, I have to define the time parameter which will be plotted along the x-axis. Here t is taken from -1 to +1 with an interval of 0.0001. Now I will take any signal. Say the signal is represented by x, which is given by half into t plus 1. Now in this graph I will plot first the graph of a particular signal. Now in the figure window I will draw 3 graphs, so I have to divide my figure window in 3 rows and 1 column. So for dividing the figure window I will use the command subplot 3, 1, 1. Here the signal required will be accommodated in the first position, so I have used 1 in the third position. Now for plotting I'll use the command plot t, x. X label t and y label amplitude will be given for labeling the signal along x and y axis, and the title will be given a given signal. Now for finding the folded version of the signal, the MATLAB command used is flip LR. So x1 is the folded version of signal x, which is given by flip LR of x. Now according to the formula of even component xc, it will be given by half into x plus x1. Now for plotting the even component, I will use the command subplot 3, 1, 2. This even component will be accommodated in the position 2 of the figure window. Now plot t, xc and x label time, y label xct, and the title given will be the even component of a signal. Now similarly, the odd component will be given by the formula half into x minus x1. Subplot 3, 1, 3 plot t, x0, and the x label will be time and y label will be x0 t, and the title will be given the odd component of a signal. Now we will find the even and odd component of a discrete time signal. Now for discrete time signal, the time parameter used is n, and its range will be taken from -10 to +10 with an interval of 1. Now according to the signal, the expression is half into n plus 1. Now I want to plot the given signal, so subplot 3, 1, 1 stem n, x. Now for labeling the signal, x label n, y label amplitude. The title is a given signal. Now for finding the folded signal of the signal, x1 is equal to flip LR of x. Now the even component is given by the formula half into x plus x1. Now for plotting this even component, I'll use the command subplot 3, 1, 2 stem n, xc. We know that the stem command is used for plotting the discrete time signal. Now x label time and y label will be xcn. The title will be the even component of a signal. Now for finding the odd component, the formula is half into x minus x1, where we know x1 is the folded version of the signal x. So for plotting, subplot 3, 1, 3 stem n, x naught, and x label time and y label is given x naught n. Now the title given will be the odd component of a signal. Now I will run this MATLAB program. The waveforms will be generated as given here. Now in case of continuous time signal, the signal is drawn with the help of this waveform. The even component of a signal and the odd component of a signal are computed according to the formula which is used in MATLAB program, and their graphs are shown in the figure window. Now similarly, for discrete time signal, a given signal is represented by the first waveform, and the even component of a signal is given by the second signal, and similarly the odd component, when it is computed with the formula used in MATLAB command, it is given by the third signal. This is all for today. Thank you.